This is a tutorial for the Bermuda Mercury. And this one, if you look at it from here, it looks exactly like a Fisher cube, and that's pretty much exactly how you solve it. The only thing is you just have to beware of this triangle down here. Okay, so now it's mixed. And the first thing you want to do for this one is to solve the yellow side first. So if you notice, even before you started mixing it, there's only one of these and two of these. So one house-shaped piece, side piece, and two square-shaped edge pieces. So the two square shapes go on the legs of this triangle, and this house-shaped one goes on the hypotenuse. So the first thing you want to do is to note that these things are also the centers. So I'm going to have that here, and this one going perpendicular to that piece. From there I can move this up here, and this piece will definitely come over here. Next I'm going to complete the would-be cross. In this case it's a triangle, and I'm going to have yellow edge piece here and yellow edge piece here. Now looking at this, I know that the opposite of red would be orange, so the yellow and orange would be coming over here. And the opposite of blue is green, so the yellow and blue would be coming over here. So here's the yellow and green, so that will come over here opposite the blue. And before I can turn it, you can see that it won't turn, and that's because this is not facing in the right direction. So I have to have this tilted over just slightly, as well as this one, and then I can now move it. So I have that piece in, yellow and orange comes over here, and I've completed the cross, or whatever you want to call it. So next I'm going to get these corner pieces. In this case there's 5 of them, 3 squares, 3 cubes, and 2 triangles. So I'll start with the cubes first. I'm going to first take this one out and put it in here. This part you do just like any ordinary cube. Now the last cube is over here. Now, if you are in the right position that you can turn these sides of the triangle, the leg sides of the triangle freely, then the hypotenuse side will not turn. So what I just have to do is just tilt it over slightly, and that side should be able to turn. So now I'm going to take this piece out. Now turn it slightly over back again, so I can put this one in here. And now I just want the triangles. Now again I have to tilt it over slightly, so I can turn the hypotenuse side. I'm going to put this one in here. Take out this red, and put it in. And up to that part, it's pretty straightforward. Now I want to get these pieces in the right place. These are the center pieces, so I have to just rotate them. Before I do that, I want to make sure that I can turn the side, so I'm going to tilt this over slightly. And looking at the surrounding center pieces, I want the green to face here and the orange to face there. So what I'm going to do is to take this whole part, flip it over 180 degrees. Now I'm going to take this all the way out again. Now from here, the orange has to go here, so I'm going to have the orange face exactly opposite of where I want it to be. Now I can match it up again, and when I flip it 180 degrees to fix this, this piece will be facing in the right direction. Now the same for the rest of them. I'm going to bring this over and over. Now the orange has to come here, so opposite of that. Now put it back in. That one's good. This one I'd have the blue facing that direction. Put it back. The center is good. Now this one I just have to flip it completely 180. Like that. So now I'm done with that. Next thing I want to do is to get in these edge pieces. And this one you do it the same exact way as you would a Fisher cube or normal 3x3x3. You just want to make sure that these two, when you're solving it, it's going to look like this. And these two squares should always be on the left and the right, or the front, right, or front and left. So first see whichever ones I can put in. Right now I can put in the blue one. So I want to have this middle cube corner piece to be directly underneath that where I want it to be. Now from here I can do the normal algorithm to put this one in. This on the left, so I'm going to start with here, this as a front, this as L. So R, you invert it, R, you invert it, and R invert it, U invert it, F invert it, U, F. And that piece is in. Now I can put it in the orange piece. Again, put this corner piece directly under the orange. Now I'll move this out to the side. I'm going to have this as F and this as L. So now L inverted, U, L, U, F, U inverted, F inverted. That piece is in. And the same for the rest of them. So here's the green. And the same for the red. Okay, now in this case there's an even number of pieces that have to be swapped, which is good, but there's another case where it doesn't end up like that, and I'll show you that case right now. So that's when it looks like this, when there's an odd number of pieces on the last layer that have to be flipped, the edge pieces. And this occurs when one or another odd number of these squares are put in opposite. So when they're put in flipped around. So all you have to do is to take any of them, since they're all the same color on either side of the edge piece, and you just have to take it out one way using the same algorithm as before and put it in another. And that should solve your problem. Now there's an even number. Now for this one, the algorithm I use involves the front, right, and top sides, U. So I'm going to make sure that I have this L shape right here. So from here I'm going to do F, R, U, R inverted, U inverted, F inverted. Now swing it around, same thing again. Going to have to do this one 2 more times. And I've gotten the cross. Next, I have to put these in the right order relative to each other. And since I'm looking around and none of them match in the beginning, so that means I can start with any of them. With any of these edge pieces. And from here I'm going to do R, U, R inverted, U, R, 2U, R inverted. Now, since there's 2 matching, I'm going to have one of them to the right, one of them to the back. From here, the same algorithm again. R, U, R inverted, U, R, 2U, R inverted. And that gets all the edge pieces correct. Now all that's left to do is to match up and then rotate these corner pieces. So first I see that this piece is already in the right spot, so I don't have to worry about this one. Now these 3, I have to rotate this here, that one there, and that one here. So it's going to go counterclockwise. So for this one, I want to use R, U, and L mainly. So what I'm going to do is, on a normal puzzle, normal 3x3x3, I would use this side. When I'm looking at the bottom using R, U, and L, I would use here and this side. In this case it can't turn, but you can notice that if it was a normal 3x3x3 and the line went through here, I would use this side, and then I would use this side, and none of them overlap. So in this case, I just want to make sure I use two of these that do not overlap. So that means I cannot go this way and then use this side, because then that piece overlaps right there. So what I'm going to do is use this piece and then use this piece, and they do not overlap. So to show you what I mean, I'm going to do this clockwise, and the algorithm for that is R, U inverted, and then it's L inverted. But before I do that, I just have to tilt this over a bit, and then I can move freely here without touching any of these. And then L inverted, U, now move this back over again so it aligns properly. R inverted, U inverted, tilt this back again, and L. And put this one back as it was, and now they're all in the correct spots. All that's left is to rotate them. Now for the rotation of these corner pieces, I use R, D, and U. So what I'm going to do is to start off like this again so I can move freely between these two. And I'm going to have this as R, making sure that the one on the right is R. Because what I'm going to do is I'm going to turn the right side, and then I'm going to turn the down side like this. And then I have to use this side again. So I have to make sure that they connect. So, first one is the green. This one turns counterclockwise. So starting from here, the algorithm for that is D, R, D inverted, R inverted, 2 times. Now I'm going to turn this over to another one that's not solved. This one goes clockwise, so the exact opposite. Before I started with D, now I'm going to start with R. So R, D, R inverted, D inverted, 2 times. Now I'll turn this over again. This one goes counterclockwise, so starting with D, D, R, D inverted, R inverted, 2 times. Move it over to the last piece that has to be fixed clockwise. So R, D, R inverted, D inverted, and the same thing one more time. And that's how you solve the Dayan Bermuda Mercury. Thank you for watching.